In this video, we're going to look at the polar form of a complex number. So it's given to you in the formulae booklet, but let's see where it comes from. Now, we've been dealing with rectangular form before, which is just 1 plus I or 2 plus I and stuff like that. So now we're looking at the angle that this complex number forms with the positive sense of the x-axis. So let's just create a complex number, any complex number. Let's call it x plus yi. And let's drop this angle, or this drop down, and have my angle theta inside it here. Now this is my modulus, the length from the complex number to the origin. We're going to call it or. That's what's given to you in the formulae booklet. So if we imagine this is an x and y axis just for now, we're going out x to this point and we're going up y to the top point. So let's have a look at my cos and my sine. So the cos of theta is equal to a over h, which is x over r. So x is equal to r cos theta. And similarly, the sine of theta is equal to o over h, which is y over r. So y is equal to r sine theta. So if this point was an x and a y, it will be r cos theta and or sine theta. But because we write our complex numbers in the form x plus yi, this complex number is r cos theta plus I times r sine theta. And if we factor out our r, we're going to get the polar form of a complex number, which is r times the cos of theta plus I times the sine of theta. So good bit of knowledge of the unit circle required here. So let's look at 4 different complex numbers, one in each sector of our real and imaginary axis. So let's take the complex number 2 plus 2i. And we're asked to write this in polar form. So there are two things we need. We need the length of r, and we need the size of the angle that's created with the positive sense of the x-axis. So we're going out 2 and we're going up 2. So the tan, we have the two straight sides. The tan of theta is equal to O over A. So tan of theta is equal to 1. So in this case, theta is equal to 45 degrees. Now, we're going to write this in radians too. So we know that 180 degrees is equal to pi. So 4 of them, 4 45s, so pi over 4 is equal to theta. Now you can write it in degree or polar form, the exam, but polar forms should be written really in radians. So what we need now is the length of r, and it's a right angle triangle, so r is equal to the square root of 2 squared plus 2 squared. So r is equal to root 8, and that's root 4 by root 2, so r is equal to 2 root 2. So my polar form, r by the cos of theta plus I sine theta, is equal to 2 root 2 by the cos of pi over 4 plus I times the sine of pi over 4. So that's one in sector in this here where all of the angles are positive. We have cos down here, we have sine in this section, and we have tan in this section. So let's have a look at one in the sine sector. And the same complex numbers get asked all the time, the ratios that work out to give angles that are easy to write. So let's look at minus 1, so it's going to be a minus x and a positive y, minus 1 plus root 3i. So I'm not going to label it down. We can just do a sketch of these, so it doesn't matter where you put it. We're not trying to draw them to scale. So I'm going back 1 and I'm going up root 3. Now I'm gonna, if it's not in this sector here, I'm gonna call the angle inside the triangle A, and then we're actually looking for theta, which is gonna be here, this blue angle, which is 180 degrees minus A. So let's start with the angle. The tan of A is equal to O root 3 over 1, which is just equal to root 3. So from your knowledge of the unit circle, A is equal to 60 degrees. which is equal to 180 pi divided by 3. So now I need or. Or is equal to the square root of 1 squared plus root 3 squared. So or is equal to the square root of 4, 1 plus 3. So or is 2. So this complex number is 2 by the cos of pi over 3 plus I times the sine of pi over 3. So if you turn your calculator to radians, you multiply 2 by the cos of pi over 3, you're going to get minus 1, and 2 by the sine of pi over 3, you're going to get positive root 3. So let's look at one in tan here now. In this sector here, they're both minus. So let's look at minus 2 minus I. So I've got my angle A inside the triangle, but the angle I'm looking for starts here and ends here. So it's going to be 180 plus A this time. So I'm going back 2 and I'm going down 1. So the tan of A this one doesn't work out evenly, so I'll change it to root 2. I'll change it to root 2 minus I. So tan of A is equal to O, which is 1 over root 2. Let me actually change it to, I'll change it to root 3. Root 2 doesn't work out evenly either. So minus 1, tan of A is equal to O, 1 over root 3, which is going to give me my 30-degree angle. So we have my angle. Now I need my modulus or is equal to, again, 1 squared plus root 3 squared. So or is equal to 2. So it's my actual angle, theta, is 180 plus 30. Theta is equal to 210. Now, if we just take 30 and say that that's pi over 6, 180 divided by 6, 210 is 7 pi, 7 of them. So 7 pi over 6's. So my complex number becomes 2 by the cos of 7 pi over 6 plus I times the sine of 7 pi over 6. And it's always a plus sign in here, because when we multiply this out, it'll give me the minus based on the sector that it's in. So let's look in here now in this sector, finally. So there's only 3 tan ratios that work out evenly. The tan of 30 is equal to 1 over root 3, which we've seen. The tan of 60 is equal to root 3. And the tan of 45 is equal to 1. So these are what they give you most of the time within these questions. They tend not to be decimals. So let's pick a complex number, 3 minus 3i. This will give me a ratio of 1. You'll see now in a sec. So just put it into the sector. We're going out 3. We're going down 3. 3 minus 3i. So I have A inside the triangle. So it's going to be 360 minus A is going to give me my angle. So the tan of A is equal to 3 over 3, which is equal to 45 degrees, which is equal to pi divided by 4. So how many pi over 4s are there in a full 360? Well, there's 8 pi over 4 is 360, which is 2 pi. So we need to take away 1 pi over 4, so we're going to get 7 pi over 4 as my angle, theta. And my or is going to be the square root of 3 squared plus 3 squared. So or is equal to the square root of 18, which is the square root of 9 by the square root of 2, 3 root 2. So in polar form, I get 3 root 2 by the cos of 7 pi over 4 plus I times the sine of 7 pi over 4. So these are the 4 different sectors where you can be asked to write complex numbers in their polar form. We've previously dealt with rectangular or Cartesian form. So just be aware of what they're asking you within these questions.